So we're going to talk about code sharing techniques. And the idea here is that when you're writing JavaScript, or really when you're writing any program of any sort, you want to avoid repeating yourself. Code sharing is the idea that you can write a certain part of your code once and not have to write it again. Why would that be important? What do you think? Saves you time. All of that time it'll take for you to type it a second time or copy and paste it. This is absolutely true. It does save you that typing time. More reasons? Yeah?
If your code changes in your shared code, you don't have to go make that same change everywhere else.
Yes. If your code changes in one place, you don't have to remember where else you typed the same thing. And this is actually the biggest thing. If you know that modifying a particular behavior means finding where it is in the code, the only place it is in the code, and changing it, then the story for improving your code is quite simple. But what if I told you that there's a code base where, in order to get a behavior to change completely and correctly across your whole program, you had to dig up however many places that code appears. It may appear in one place, or it may appear in 2, or it may appear in 10. The story for you improving your code goes, read every single line of code in the entire system, determine whether that particular line of code is intended to solve this problem, or relate to this behavior, and then change it in as many places as you find it. This is the main reason that code reuse is so important. You don't want to type the same behavior twice, because you don't want to doom the next developer to reading the entire project looking for the number of different places, however many number there might be, that you have written that behavior. Does that make sense? So that's the intent of code sharing. Let's look at what techniques you can use in JavaScript to accomplish it. So, the first, I'm going to kind of coast through some of these because we don't need to explore them in such detail, but the first is just state caching. If I have a long equation, a long math equation, that I'm going to, like it calculates pi, I might decide that instead of typing out that equation every time I need to talk about pi, I would just save it to a variable named pi, and then I can reuse that variable name, and it will speak to the same idea that I specified one time when I was creating the variable and storing this value in it. This is a kind of like very simple level of code sharing. Another type of code sharing is functions. When you write a function, you're basically saying, I believe I need to compute the output for some operation more than once, potentially very many times. So instead of writing out a big block of code every time I need to draw that type of conclusion, I'll write one function, and I will call that function whenever I would have written that big block of code. Another one is mixins. So in an object-oriented paradigm, where you're using some construct, like a JavaScript object, to represent the encapsulation of a bunch of related information, you put all of the related data together on an object, you might want to pepper a lot of different objects with similar data or similar methods. The notion of a mixin is the idea that you will pepper onto a given object the added nature that you want it to have. Thumbs on your sense that you could explain what the mixin pattern is and why it's valuable. I totally know. I'm still kind of trying to keep up with your point there, somewhere in the middle. Great. Let's iron that one out, because that's a lot of confusion around mixins. So, there are car manufacturers in the world. They make cars from scratch. You call them up, you say, hey, I would like a car, please. And they say, sweet, give me a second. And they go to the big car factory thing, they press a button, it starts assembling cars. Out the other end comes a brand new car. That's the fabrication story. Limousine, you wouldn't call them manufacturers, limousine providers have a bit different story. You either bring them an existing car and say, please make this into a limousine, or they go out and find a car and augment it to be a limousine. But in any case, they're adding limousine nature to an existing object. Yeah? This is a very good analogy for a mixin. Anytime you have a fabricator or a producer that does not generate the item itself to begin with, it just augments an existing object with added nature, that is a mixin. That's the mixin story, as distinct from the fabrication story, the construction story. In JavaScript, that means for a given object, you might want to pepper in some data and or some methods that are the same as what you might pepper into another object later, or into very many objects eventually. You build a mixin that's capable of extending some target object with a bunch of useful data or useful methods. So, you there. Could you tell me what your sense of the value of a mixin is? What it is and what problem it solves?
From what I gather, it sounds like it's almost like a mini library that you would have that's kind of generic of different actions and things you can do, and other objects can leverage without being affected or affecting the central.
Okay, let me drill in on your statement and then provide you a delta from what you said to what I actually mean. You were pretty correct. Here's what you said, as I understand it. You said, it sounds like a mixin is a library where parts of your code and perhaps objects within your code can make use of shared functionality without something. I missed the last clause. Without perhaps dependency, or I'm not sure what you were driving at there. This is pretty correct. You're very much on track. But the thing that's missing is the idea that a mixin specifically adds functionality to an existing object. So let's say I have some factory in my code, a class, a constructor, that builds user objects. And some users I want to make admins. I could have an admin mixin that takes as input a user object and augments it with all of the special stuff that admins can do and all the special data that admins have about them. And then now that user from that point forward is more detailed and more specific and has more capabilities. That is a mixin. It's distinct from what you said in one subtle way. Underscore is a library that satisfies what you were proposing. It's a pre-written library with shared code that you can use to, but underscore does not provide functions that get tacked onto an object you built and that you have in existence. A mixin is specifically a type of library code that augments an object with more interesting and more specific nature. Thanks for playing along. Yes?
So from the last session, would the add events, when you called
Yes.
on target, would that be a mixin?
That's a great observation. The event system augmentation function that we wrote, that's a mixin. It mixes event binding nature, eventable nature, onto any object. I hadn't thought. Great observation. Yes?
Is there ever a case where a mixin can override functionality that's defined in the class?
Absolutely. The question was, can mixins ever override or perhaps delete functionality that existed already in the object that they're augmenting? Part of mixing into an object and augmenting it may be an aspect of removal. It doesn't tend to be used that way because I don't know why. In practice, that doesn't come up a lot, but you could totally posit the existence of a mixin called the Zen Buddha mixin, and it mixes in the Zen Buddha nature, which is to say it deletes all of the pre-existing knowledge and information and methods and properties that used to be there, and then you have this perfectly Zen little object that isn't overcomplicated with anything, right? That's a valid use of the idea of a mixin. It just never occurs in code. You specifically asked about overwriting. It may also be the case that an object comes in being able to do a thing one way, and it comes out being able to do that same thing differently. So we might have a car that has a drive method or a move method, and you mix in the race car nature, and all of a sudden the same object that just had a move method, and that's it. It still has a move method, but that move method is faster than it was before. Yeah. Any other questions about the mix-in pattern and how it represents a code sharing technique? Thumbs on whether you could explain how mix-in is an example of a code sharing technique, how it would be used to share code. Could you tell me what you think, how the mix-in pattern could be used as a code sharing technique? How it satisfies the definition of a code sharing technique?
So rather than having to go back and rewrite everything, if you found an area where you wanted to modify it, you could use some code you wrote in one area and apply it to the mixin, or sorry, apply it to the code to create a mixin so that it modified something without having to go through line by line and find it all.
That's close. So I think what you said was, rather than having to write out code twice, you could use your mixin. I'm going to have difficulty phrasing it the way you phrased it, but I'm just going to take what you said and shape it up a little bit to mean exactly what I mean. The way in which a mixin represents code sharing is that you may have very many objects that you want to have a similar type of nature. They should all have the move method or the swim method. A bunch of objects all need the ability to swim. So user 1 needs the ability to swim, user 10 needs the ability to swim, and user 55 needs the ability to swim. But none of the other users need the ability to swim. Rather than type out the swim function 3 times, once for each of these users, I'm going to create a mixin. I'm going to pass each of these 3 users into my mixin, and it's going to augment them with the swim ability, the swimming nature. So that's why I won't have to type code twice when I'm using the mixin pattern. I'll get objects that suddenly have the swim method, but I only typed it 1 time in this mixin augment. Any questions? Okay.
Oh, I'm sorry.
Yes.
So your mixin would probably have more than one thing in it, because otherwise you lose the efficiency of the whole point of the mixin, which should have multiple things in it, because otherwise you could just have one line of code, let's say swim. But it should have a
this is a fantastic question.
Right, so you're not just abstracting everything. Kathleen?
Kathleen's intuition was that a mixin must necessarily consist of more than one line of code. Because if it's only one line of code, you're not saving anything in all of those other places. But let's rewind to where I made the claim about what I thought the value of code sharing was. One reason was to save time, and you're right, you're not going to save any typing time if your mixin is only 1 line long, because you either mix this thing in, or you write, well, I'll just write that 1 line of code here. But the thing that I actually thought was more important about code sharing was the idea that when you go to refactor your code, and you want to change how something works, you want to change it in exactly one place. If you've rewritten a single line of code many places, rather than using a mixin to accomplish that, then the refactoring story is pretty complicated. The refactoring story says, you know, I didn't bother making a mixin because it was only 1 line of code, and so I typed that 1 line of code in 10 different places. And now I want to change how that behavior works. I don't want it to just do this one sort of thing. I want it now to do the slightly different thing. Or I want it to do 5 things in each of those places. I have to go to all 10 areas that I typed that one line of code and modify them all to be in sync with my new understanding of how the code is supposed to work. Does that make sense?
Yes, but in a CSS example, I've seen display block get abstracted as a display block mixin. And so there's one line that gets added in that's abstracting the display block when you could just put display block. Like having that as a single property all by itself was unnecessarily abstracted and confusing and
True.
So
True.
You wouldn't change something that was called that specifically display block. You wouldn't add functions to it because then it wouldn't be display block anymore, so you should be more general about it.
This is a great point. I would never create a function called add1. I would never write a code sharing abstraction that specifies what it does so completely that I couldn't possibly change that abstraction. So not only would I not do the example that Kathleen brought up with the CSS, I also wouldn't write a function called add1 to number. Because adding 1 to a number is not only simple to do everywhere that I would call that function, I don't really give myself the opportunity of changing what the add1 to a number function does. The name of the function already specifies such a specific thing that I don't really give myself any leverage for updating the code later. This is a good point. Nonetheless, if the name of the mixin is something general, even though the mixin does only a single thing, I'm probably going to use a mixin so that my editing story, my refactoring story is simple. This is a great question. Classes. Let's say you have a system that needs not just one, but very many of a given sort of thing, like users. You're writing a program, and lo and behold, you get more than one user, and you suddenly need many users, all of whom have the same kind of like methods on them. These user objects in memory all have the same methods, but these user objects all have the same methods. You would create what we call a class. A class is a structure, a construct in a programming language that allows you to produce a fleet of similar objects. I'm going to say that one more time because it's so important. If you've heard a lot about OOP and you're like, oh, that's intimidating, I don't know what that is. Or like, one day I really have to learn OOP. Or like, you know, object-oriented programming, everybody, it's all the rage. And I'm trying to sort of like sound like I know what I'm talking about. So I say the word, you know, method and static from time to time so that people think that I'm also one of the cool object-oriented people. If you felt this way about object-oriented programming, congratulations. We all feel that way. It took a while for me to realize that object-oriented programming is a very, very simple thing, and much of the hubbub around it is unnecessary, you know, trappings. Basically, object-oriented programming boils down to this. Let's say classes boil down to approximately this. A class is a construct that a programming language provides you, or that you create in your programming language. Any construct in a programming language that can produce a fleet of very similar objects. In the real world, can anyone think of an example of something class-like, but in the real world? It produces a fleet of very similar things.
It's my favorite example. It's like if you have a cookie cutter and you produce cookies. So
Yes, a cookie cutter. A cookie cutter provides the ability to stamp out a ton of things that are all star-shaped. Same was true in my example with the car factory. The car factory produces a bunch of similar objects, cars. Now, one car is different from another car in as much as they have different locations, different speeds, different owners, different colors, but they're very similar. And so in the real world, when I notice that I'm building a lot of cars, I stop building them by hand one at a time, and I build a factory to kind of make that simpler. So that's a class. Are there any questions about classes? I'm kind of curious. By show of thumbs, can you tell me how how perplexing the idea of classes and OOP generally was before this conversation, regardless of how this conversation might have changed that. Before we talked about it, how much sense of confusion or conflict or ambiguity was there around the idea of a class and object-oriented programming? I basically have been faking it, thumbs down is I've basically been faking it. I totally did not know what it boiled down to, or like, yeah, everything you said kind of made perfect sense to me even before you said it. An even split. All right, so that's a class. Subclassing is when you want to build a factory that makes a derivative type of object from some other factory. So a limousine could be implemented as a subclass, a limousine producer. Could be implemented as a subclass of, what do you think? What's that? Of a car factory, yes. So a limousine producer, a limousine factory, might be a subclass of a car factory. Car factory produces many cars. Limousines accept instances of a car and like turn them into limousines and pass them on. A subclass is any class that is based on a pre-existing class and just extends the definition to be even more specific. Methods, we can put functions on objects so that they follow those objects. This is a technique of code sharing. And then JavaScript provides us prototype chains. Prototype chains allow us to put a method or some shared data in a single place and see it exhibited all over our code. So rather than tacking code onto many different objects, we can tack code onto one central object, and everything that delegates to that object will appear to have those aspects exhibited. Prevents us from having to write code that augments each object with the same stuff. Yeah?
So, unfortunately I missed your prototype chaining yesterday, but isn't that a form of subclassing in JavaScript?
No, a lot of people confuse the idea. Great question. Aren't prototype chains themselves basically subclassing? No, prototype chains are a mechanism by which an object can delegate failed lookups to some other object. It's a rather simple mechanism that can be used in a lot of different ways. I could, for example, use prototypes and prototype chains for not subclassing, but just instantiation. All of the cars in a system could delegate to a single car prototype, and without any subclass of the notion of a car factory, I'm still using prototype chains to share methods across a bunch of instances. So subclassing and prototype chains are not quite the same. And in fact, you can even use prototype chains for non-class related things. It's just hard to come up with good examples because they're all rather contrived and no one would do them. Prototype chains, simple mechanism, can be used for classing and subclassing, but don't have to be, and are rather useful there if you choose to. Good question. So let's dive into what it looks like in JavaScript to use some of these techniques. Specifically, we're going to explore mixins, methods, functions, and classes. In the gray here, we have some target consumption code. This is what our users are going to want to type. Somewhere, this is like a racing game, yeah? The racing game code lives here in the gray box, and we are going to gradually build library code that supports the racing game so that it's easier to write our racing game because we abstract things away into a library of racing game abstract library code, classes, mixins, etc. Premise makes sense? Any questions about what we're about to embark on? We want to satisfy this code, and as it evolves, we're going to notice problems with it in refactoring. So here's what the code says so far. A buggy is an object. This open curly brace starts an object. There's one property on the object, the location, so this buggy is going to be put in some random spot. And then an end curly brace because we're done defining that object. Then we move the buggy one forward. Our program Our racing game is small and boring. To observe this program is to notice that a buggy starts out somewhere and goes 1 unit forward, and then we're done with our program. We keep writing our program, and we do the same thing to a Viper. A Viper starts out in a random location and moves forward 1 unit. And already we're noticing code duplication. And so we say, how can we avoid this? What is the simplest way you can think of to avoid this code duplication? Either. Right, yeah, great. We'll make a function. Let's make a function that builds these objects. Make car does the exact same work that was being done twice here, but my refactoring story is made easier. If I decide I want to augment cars with something, I'm only going to have one place to edit. So this red code is going away, and in its place we're just going to call the make car function. Notice that in the old story, if I decided Buggy and Viper need more stuff on them, I have to edit 2 places, right? In the new story, when I decide Buggy and Viper need more stuff on them, I edit 1 place. So the make car function is useful in that it prevents us from writing the same code in multiple places. The make car function, by the definition we provided earlier, is a class. Who remembers the definition from earlier? Thumbs on how well you recollect the definition from earlier. Super well. Please don't call me. What was your recollection of the definition of a class?
Like a group of objects that are all similar, or all...
Very close. Your definition that you provided just now was a group of objects that are very similar. In fact, a class is a construct that allows you to create that group of similar objects. But same idea. Awesome, thank you. Make car is a function that can produce many similar objects, right? So it's a class. Now, those of you who are familiar with C or Java or any other language in the world that has object-oriented features are just inside, you're torn up, you're like, no, it's not a class, it's just a function. I just nearly knocked my computer over. It's more than just a function, because those other languages introduced a lot of baggage around the idea of a class. If you're coming from another language, you probably imagine that other languages, or rather, you probably imagine that what those other languages offered you are intrinsic and necessary and crucial for the idea of a class, but they're not. The idea of static methods is not a necessary idea. JavaScript does not provide such a feature. You can kind of achieve it, sort of. But if you imagine that something must provide that feature in order to represent a class, I would argue that instead, anything that produces similar instances is a class, and therefore this counts as a class. I can certainly use it as one. So if we write this a little bit differently, it's going to make it easier for me to refactor over time. Let's make a variable called results that stores that thing, and let's put this property assignment on a separate line. I'm only elaborating this out to help my slides evolve more gradually. I don't want to surprise you, but notice that this version of the code does the same thing as this version of the code. Are there any questions about the version of the code that's up there? Are there any syntactic tools I'm using that are confusing to you or don't make sense as to what the make car function is going to do? Okay. What else can we factor out? With the red hair there. Red-haired people always know I'm talking to them. They're just like, oh, that's me. That's definitely me. So factored out specifically out of this gray area. Buggy equals make car, buggy.location++. Viper equals make car, viper.location++. What's that? The increment. Yes. So this movement behavior is repeated. And if I decide that movement should go more than one unit forward, my racing game was too slow and boring, I want it to go 10 units forward, I'm forced to edit that in two places. The movement behavior is specified as an increment of 1. So instead, maybe I would factor it out into a function. If I delete these lines of code and in their place, I'm going to use a function, move, that takes a car object and increments it by 1. Then all I have to do is call that move function on the car, and it moves. Kathleen, could you frame for me the improvement that we see as a result of the fact that we are no longer using these lines of code? We're instead using these 2 lines of code that talk about move at a high level. What is better about my life as a programmer interacting with this program because the code looks like this instead of like this?
Move is available to other objects you might create later.
So later I can call the move function a 3rd time. That's one improvement, but I would argue there is a larger improvement as well. And the last time that we spoke, you and I, you went to the time-saving improvement, right? You said it saves you typing a thing again, which is the same claim you're making now. And I retorted that there's a bigger improvement that we can observe. I'm actually making the same claim now. The same larger improvement that existed before exists here.
It's less typing? I mean, is that what you're saying?
No. So the less typing part is, in my opinion, the weaker of the 2 improvements, although it is an improvement. There is another improvement with helping.
Well, you can add more things to the move function, and it will then be replicated everywhere you call move.
Exactly. My refactoring story is made simpler. If I determine that move is working poorly and I need it to work differently, the refactoring story goes, find the move function, edit it once, and you're done. As opposed to find the 30 million places I've ever called move, or the 30 million places that I manually incremented the location, and start making them increment differently, or more, or better. That is a very important transition in our code. Even though it looks perhaps more complicated, because now we got this other function. It's actually way better for us. I'd like to speak to your CSS example. Your CSS example was really great. But before you said that the CSS class was named display none, I was worried that you mistook something that was a good idea as being a bad idea. You were right that it was a bad idea, but if that class, if that CSS class that abstracted out the idea of displaying none into a class called display none, if it had not been called display none, it would give us this same leverage. And so there are places even in CSS and even in one-liner things like this where the added complexity that you complained about, you said it's more confusing. You're absolutely right, it's more confusing. In this case, I would argue the added confusion is worth it. The fact that we've moved the behavior out to a function makes it worth it for this refactoring story being improved. If we were instead to have named this move forward by 1, then maybe it wouldn't make sense to factor it out because we're forced to go change the function name everywhere if we decide to actually move forward by 2.
So in this case, you've made a mixin for car for move, and I'm assuming that somewhere down the line it's because you're going to want to apply it to a train or a boat or something else that has a move concept. But if this was an action that was more specific to the car, would you have instead put it inside of make car?
Can we put move inside the make car function? We totally could have, yes. And you've guessed correctly as to where I'm going with this. I'm going to reuse the move function in a lot of different places, but I totally could have used, I totally could have defined the move function right within the car function, make car function, since the only application of move right now seems to be on cars. So that also kind of cues another improvement here. Object-oriented programming, one improvement that it promises is a bit easier syntax for how you talk about encapsulated behavior and data. So let me start with a simple statement as to what I think object-oriented programming is good for, why we use it. Object-oriented programming allows us to encapsulate together related data and behavior. When we have an object in our system, an entity that we want to mutate. So we've got a racing game, and we think of the Mario car as being rather distinct from the Yoshi car, and we want to encapsulate together all of the things that are true about Mario's car, and we want to keep them separate from everything we think is true about Yoshi's car. We can use objects to do this encapsulation. Objects provide us an envelope for putting all of the data, the color of Yoshi's car, how damaged it is, the speed it's currently going. We can put all that together. Currently, that's what we've got here with makeCar, encapsulation of data. Object-oriented programming goes it one step further and says, maybe we could put the behavior itself in with that object. Maybe we could say that Yoshi doesn't just have data, the Yoshi object doesn't just have data about itself, it also carries with it the ability to move. And this means I can use what I think is a more intuitive syntax. I'll delete buggy as an input to move, and I will add buggy before a dot. Looking at this here, buggy.move, to me that feels like a more intuitive way to think about movement than this, where we pass buggy into a movement function. There are a lot of little benefits, like if I were to pass buggy around in my system, I pass it and some other file somewhere needs to tell the buggy to move, the behavior is going to go with it. I pass it to that other system, and that other system can just say, well, the car I received .move, and it's going to work. As opposed to that other system needing to somehow go find the move function, load it as a dependency, or receive it as a second input to that system. Do you see what I'm saying? I would claim that encapsulating the behavior in with the data, we get an improvement in how we can think about our code. That was one of the major revelations of the object-oriented programming movement. The sense that cobbling together not just a bunch of related data, the way that a C struct, if you're familiar with C, a C struct is like a composition of data. I don't believe C structs give you methods. And then in addition, you get behavior along with it. So let's achieve that with JavaScript. We want our code to be able to move the buggy reference to the left of the dot. We know about this left of the dot thing. It's probably going to rely on the keyword so when I talk about left of the dot, does that remind you of a specific construct that we discussed? You might not have been here for this lecture. It's entirely possible. The keyword this, yes. We said that the keyword this is exactly like a function input. It just appears differently in the calling context. The binding doesn't look like this. This is not how you bind the keyword this. You bind the keyword this by putting that input to the left of a dot. Make sense? So, if we want to facilitate this syntax, and we're going to be moving away from this syntax, the way we accomplish that is by adding move as a property of result so that this dot access will work at all. Yeah? We need move to be on the car objects that are produced by this factory. So we say, hey, the move method, the key move, maps to this function. And that means buggy.move will have meaning. But we also need to think about this. All of a sudden, buggy.move doesn't take an input, right? So this has to go away. And if this goes away, obviously we need to fix that. The keyword this gives us a solution to this problem where we want move to operate on something to the left of the dot, just so that we can facilitate this encapsulated version of a function call. So we use the keyword this in our move function to allow buggy.move, paren paren, to work correctly. So we just made a few big leaps in a row, and I want to like pause to collect your general anxiety about life. Are there any questions about all of this new code on the screen? Yeah.
So I don't know if this is really junior, but why would you initialize your variable result with an empty object, and now you're filling it with, I understand you're trying to encapsulate the data and the behavior together, but why wouldn't you have just kind of gone into that to begin with?
What? Sorry.
I guess
the trouble I'm having is that I missed a few words to, just volume-wise, and I'm trying to cobble together
sure.
your question.
I'm trying to understand why start off your function with that empty object set to your variable result. Were you just doing that because we were going to move into filling that later, or?
So the reason that my slides started out by having result have an empty object is because that was a direct improvement, a direct analogy to the code that I was improving. And I'm improving it as slowly and gradually as possible so that we can talk about each improvement independently. When I made a function that did all the work, this was all that I needed to move over. I elaborated that out into a few steps, but at this moment, we didn't have the idea of move being we didn't even have a move function at all. I introduced move as a separate idea. It was a slight improvement on our old code for the reasons that we talked about with like high leverage. I can augment this function once and it updates every use case. And it wasn't until I did that I noticed the opportunity for a further improvement. In fact, if JavaScript didn't support object-oriented features, this is where my code would have to stop. If JavaScript didn't have a keyword this, or didn't have method encapsulation, then this would be the entirety of what I could do. I can only improve my code further because JavaScript does allow me to encapsulate functions within objects. Does that address your question?
It does.
Okay, cool.
I have a question.
Yeah.
If we move the move function inside the result object, that's going to create a conflict, right? Because you don't have this dot location yet. You understand what I'm saying?
You're saying, as we are running this code and we say var buggy equals make car, that's going to jog us over to here. We will make a result object that has one property at the key move and stores the value that this variable resolves to, this function, right? And already you think we might have a problem because the move function we're tacking on talks about a location property that is not yet on this object. But remember, this code between these curly braces doesn't do anything until we run it. It's wrapped up in saran wrap until someone presses the go button on buggy.move or result.move. So until the move function is invoked, the presence or absence of a location property is irrelevant because this inner code here is not running. Does that make sense? Notice that the next exact thing I do is add a location property, so there isn't really any time for the move function to get called while location was undefined. Unless someone goes in and types result.move in between these two lines, which would be clearly a bad idea, there will never be a moment when this code inside the move function could possibly have run in advance of the location becoming available. Cool.
For consistency, you could define the result object to be move, comma, location, math random?
Yes, I could use the same property definition syntax for both of them. As it happens, I've used two different ones because of how the slides evolve. It makes the deltas smaller, but it does introduce this problem that you guys have to use two different syntaxes in your minds at the same time. By the time we return a result, it has two properties on it, but we added those two properties in two different ways. And that's a very good observation. Here we added the move method one way, here we added the location property another way, but they amount to the same thing. They're both adding properties to the same object. Okay, now we get into some of the more complex or advanced code sharing patterns. Imagine we wanted to make an object that is quite similar to a car, but somehow significantly different. Let's say a boat. So we have this skiff that we want to build, and here's a question mark saying, what are we going to type there? What are we going to type there? What do you think we could type there with the glasses?
I wasn't paying attention.
I apologize. Well, let me step you through it just so that we can, I don't mean to interrupt, I'm sorry. You can totally be doing other things in this class. That's really fine.
I was reading through my notes, I'm sorry.
That's okay, it's okay. I actually totally think it's fine, especially at a conference, to be doing other things. The reason I kind of work with you guys as much as I do is because I don't expect you're going to be completely on the ball, so thank you for playing along anyway. In this case, we want to build a skiff, which is a sort of boat-like object. It's going to have a lot of similarities to cars, such as probably movement, right? Having a location. Those are things we want a boat to have too. But it might be somewhat different. Before we think about the differences, let's just assume that boats are just like cars. They're identical, in fact. What could we use here to create a new boat? What function could we call and substitute in place of this question mark that would allow us to make an object, the skiff, would hold?
Instead of bar skip equal to make car?
Yeah.
Is that what you're asking?
I can reuse the make car function because currently there's no difference in my mind between a car and a boat. I can't think of how they're different yet. So yeah, we'll use make car, no problem. But someday I might determine that my program needs to distinguish boats from cars. The first time I try to build a rolling behavior for cars, and I go in here and I add the roll function to make car. When I do that, suddenly boats make less, skiff makes less sense. The skiff should probably not have the ability to roll anyway, right? What I probably won't want to do is skiff.roll. So I suddenly need not to have this make car be what I call. I really need a make boat function so that skiff can do whatever boats do, like floating. Skiffs will float. So I need to refactor my code to accommodate this new demand on my code, right? The user is going to be typing this. I had better refactor my library so that cars come out the way they need to come out, and boats come out the way they need to come out. Cars with a roll method, boats with a float method. So let's build a boat maker. This is a function. It's a class, like the make car function. And it seems to do a lot of the same stuff as make car, with the caveat that I'm going to add in the float method. And now, everything works, right? You dig it? Are there any questions about differentiating these two functions? Yeah. Yes, you're absolutely right. There are a lot of similarities between make car and make boat. How would you solve that?
Maybe make vehicle and then have
So you're positing exactly the right stuff. You said, maybe we could make some shared code that both of these functions would rely on. They would both call out to a vehicle maker or something like that. Let's use the mixin pattern, because I think it's the simplest story we have available for this situation. Here we have the shared code. In red is the code that I don't want to be repeated. All of the rest of the code looks to be either completely necessary for my function to work or unique. These two functions are unique. I don't want them to, I couldn't call them shared. And the variable definition and the return, I can't factor those out of the function. But I can factor out all of this red code. So what if I was to make a function that did that? I will make this mobile function, and the green code is going to be added and the red code is going to be removed. Basically, I'm taking all the red code and moving it out to a function. So let's just examine that transition in detail. Move, this property, we want to add that property in our shared function, and location being set to a random value, we want to do that in our shared function. The mobile function is a mixin that takes some object, right? Here is the object, the open curly brace followed by the closed curly brace. It augments it with a move method, it augments it with a random location, and it returns it. I'll give you a second to read that code, and then I'm going to ask whether you understand why this stuff, these few lines of code, satisfy my definition from earlier of a mixin pattern. The mobile function satisfies my definition of a mixin pattern.
So you passing an empty object to the mobile?
Yes, mobile is a mixin. Much like a limousine producer is a mixin, you offer a limousine producer your favorite old car, and you say, I love this car, can you stretch it? And they say, yeah, sure. I'll augment it with all of the stuff that limousines have, like a TV and a sort of long center part and stuff like that. A mixin, by definition, takes as its input the object it's going to augment. So what do you think? Do you feel like you could explain to me why the mobile function satisfies my definition of a mixin? It does what I claim mixins can do?
So you're passing the object in and using that inside the function?
Yes, you are using it inside the function. So condition number one is met. We pass in a target object. Condition number two, I think we can specify more specifically, right? You're using it. What are you doing with it inside the mobile function?
Let's see. Moving into the results, returning it as a result, a random number.
We're augmenting it with those two properties, yes. A mixin takes as input some target object and does the work of augmenting it with nature, with additional nature. Make sense? Cool. So, the mobile function satisfies our definition of a mixin because it does those two things. In the back, in the green shirt, it's a very lovely color, by the way, I'm curious whether there's anything on the screen that looks confusing and that I can clarify.
No, I was struck for a second there on you call it the mobile function. You like their car without equal formal, but you're basically passing in an empty object.
Yes.
Which is your result.
Yes. Yes, so that is a very interesting property of this code. He was observing that we seem to be building the object outside of the mobile function and passing it in. You would correctly determine you would be reasonable to complain that using a mixin here seems like an odd choice, since we don't have an interesting object to begin with. The thing that we're asking to augment is an empty object. So why is mobile a mixin at all? If the only way we ever use it is to pass in empty objects, it seems kind of silly. Maybe mobile could make the object for us, and then we wouldn't have to pass in empty objects in order for it to work. This is a reasonable complaint, and I'm going to refactor the code so that instead of being a mixin, we have a class, the mobile class. But there's a reason we might prefer to have mobile remain a mixin. If other parts of our code had interesting objects and already in existence, and those other parts of our code wanted the ability to augment them with mobile nature, then we would need for this code up here to be written exactly as it is, accepting a result input that it augments, so that those other parts of the code can just make, bugs mobile, and make, basketballs mobile, and every other type of object. But as it stands, our code does not reveal this advantage. So it's reasonable to look at this and think that that's a little bit cockamamie. I haven't had an opportunity to use the word cockamamie in a while. So let's start this refactoring process. If instead of passing in the object, I wanted to remove these curly braces, I might rename this function, instead of mobile, which is like an adjective that describes a noun. Usually we name our mixins as adjectives, so that it reads rather naturally a mobile version of this object. Instead, I'm going to name it the way we name our maker functions. It's saying, hey, make a mover for me, so that when I remove these curly braces and I take out the result, and instead I just make the result here inside the function, this becomes a class. Make mover builds its own result and then augments it and then returns it, meaning I don't have to pass it in. We have just transitioned from the mixin pattern, which is useful in some circumstances, to a class pattern, which is useful in approximately a subset of those circumstances. Different circumstances. You are now equipped with both techniques. You can do both things. My example is one tiny situation where you might want to do that. It's rather contrived, but it is contrived so that I can keep a minimal amount of code on the screen. You will encounter much richer and more interesting examples in your day-to-day coding life where you're like, wow, I have a bunch of objects and I want them all to be similar. Maybe I could mix in a behavior into all of them. Or you might notice, this is awkward. Instead of a mixin, I'd rather just have a class that produces the object in the first place. Depending on your code and your use case, you'll notice that you would prefer to use one or the other construct. Are there any questions about either of these two patterns? Yeah.
So then, if we're looking at cars and boats now, is something made a subclass by also having the characteristic of creating objects, or is it a subclass by just sort of existing within the umbrella of the original class?
That's a great question. What is the exact definition of a subclass, and do make car and make boat qualify for it? Absolutely, pertinent. I would say that make car and make boat do qualify for my definition of subclass. They are subclasses of the mover class. And the reason I would say that they are is they rely on a class to define the basics of what they produce, and then they produce a more detailed, richer version of that same thing. So the simplest way I know of to define a subclass in any language that has sufficient support for like passive functions and passing objects and augmenting objects dynamically, etc., etc. JavaScript has a bunch of features that enable us to do this. The simplest way I can think of to define a subclass is to have it call some superclass, save the result, augment it, and then pass it off like it made it. So the difference between a limousine factory, a subclass of a car factory, and a limousine mixin is that the limousine mixin thinks I'm supposed to bring my car in. The limousine mixin producer says, if you bring us cars, we will stretch them. The limousine factory, which is a subclass of the car factory, orders the car for you and provides it. It's a brand new car you've never seen before. You never saw it pre-limousine before. This qualifies for classhood and uses the same construct that a limousine factory would. It calls out to some superclass and says, that's what I'm going to use as my base, and I'm going to augment it.
So because just a moment ago when we were using the mixin, the burden of creation was on the make car and make boat, that made them classes as opposed to subclasses now, because the, yeah.
Yes, absolutely. So the point that this gentleman just made was, back when we were looking at this version of the code, and the burden of creation of this instance was on the make car function, rather than on the mobile mixin, you can't really claim that make car is a subclass of anything. It relies on a mixin to do some work, but since it generates the object, and it doesn't ask something else to generate the object, it is not called a subclass of anything. It's specifically not called a subclass because it's not derivative of any other class. There aren't any other classes to be derivative of. Great point. That's it. We have now used functions, constructors, well, not constructors, but maker functions, classes, and mixins, and methods. We've used all of these code sharing techniques over the course of refactoring our code to be better and better. And we've seen like subtle motivations why we might want to transition from one to the next. So, this started at 11:40. I am right at my 1 hour goal, although I started 10 minutes late. Thank you for pointing out that we were about to run over. We have 15 minutes for you guys to play with the exercises. There is a rather inconvenient aspect of the way that these lectures are sequenced. Inconvenient for me, certainly. And that is, the exercises target your ability to use all of the information you've learned here. And the place where I get to tie it all together for you is the next lecture. In the next lecture, I get to show you how I would approach the exercises that you are doing. It is probably very difficult for you to refactor the class patterns to work from one pattern to another using these simple primitives that we've shown you along the way, because it takes some ingenuity to apply the ideas we've said to an actual real-world practical example. And so in the next lecture, what I'm going to do is navigate exactly what the prompt asks you to do, and dispel any mystery you might see in what motivates the transitions in the code that you are called upon to do in those exercises. And unfortunately, it's not possible for me to deliver that lecture until I've shown you all of these different techniques that we've learned over the last couple days. So, what I ask is that you do your best, you open up the exercise, you try to apply the idea of the keyword this, try to apply the idea of prototype change, try to apply the code sharing techniques that we're talking about, and make as much progress as you can with the support of our TAs, and then the big sort of whammy reveal will take place in, I think, 15 minutes. If you have further questions about this lecture, why don't you please come to the front. I'm going to stop shouting at everyone and transition towards more of a TA-supported circulating structure. Try to get to the point that you are familiar enough with the assignments that you have a lot of context for what I'm going to show you about how I would approach it. And if you have more questions, come to the front and we'll talk about them individually, sort of independently, in a little group.
Well, this might be for everyone because it's about scheduling.
Yes.
So what do you think is next?
I believe that next is the, what is next?
Well, next on this list isn't until 3 o'clock, which is Crash Course in Backbone.js.
Ah, right. Well, when does, so then 4 o'clock is the...
Secrets and Lies about JavaScript classes.
Got it. So at 4 o'clock, we will go through Secrets and Lies of JavaScript classes. It will tell you how all of this stuff works. It gives you plenty of time to work on these assignments with the support of our TAs. At 3:30 is a Crash Course in Backbone. That's more of an advanced thing. If you're interested, sorry, 3 o'clock? Did you say 3? So at 3 o'clock, we'll do the Backbone thing. If you're just interested in Backbone, feel free to take a break from the mainline exercises. But it will not be kind of part of the point of our overarching thing. That's just there so that if you are interested in an advanced, accelerated introduction to that stuff, you're more than welcome to join, or you're more than welcome to keep working on the assignments here. The TAs will continue to support you through that half-hour lecture. And if you have questions about this lecture, please come to the front. If you have questions about Hack Reactor, the school that developed all of this curriculum, feel free to talk to my brother Tony or myself or any of the support staff. Cool. I'll see you all much later on. Oh, lastly, sorry. Last scheduling issue. We are in this room starting up right after lunch, even though that's like what, 1:30 or 1?
In 15 minutes.
Lunch is at 1, but then 2 o'clock.
2 o'clock.
We have an hour in this room where we are going to be here to support you guys, but there's nothing on the schedule. Like yesterday, this will be a workshop time when we work really hard with you on those assignments. So I invite you to come join us at that time for making a lot of progress. All right.